There's also this notion of comparison. This is something else that can be done if you're testing, let's say, a new kind of treatment. Instead of giving the control group what's called a fake treatment, you could give them a treatment, but you can give them one that's already been accepted, I guess, into medical practice, one that has been proven to work. So a more conventional one. So in other words, if doctors, let's say, are testing a new kind of treatment for something, whatever it is, I think the example here was cancer, instead of giving one group a placebo, which does nothing, they might use a currently accepted treatment. You might be thinking, well, why would they do that? Well, because you don't want to take a chance of denying anybody treatment, especially for something like cancer. Again, with placebos, it's a dummy treatment. You're not getting anything really. Okay, you're getting a sugar pill. How's that going to help you, right? But with this, with comparison, they are still getting a treatment though. It's just that they're testing a new treatment on another group of people, the treatment group. Okay? Of course, though, conventional one is a treatment that has been proven to work. So it's not like they're getting, they're basically getting some kind of treatment is what I'm trying to say. Okay. Also, this is something else you should know. With these placebos, I think I might have forgotten to mention this. This is why I got confused for a bit. You're not telling the participants if they're getting a placebo or not. You're not telling the group, this is the control group, you guys are going to get a fake treatment, okay? You're not going to tell them that. That would defeat the purpose of the placebo, okay? So you're not going to tell them, you're not going to tell which group is getting a placebo and which is actually getting a treatment, because that would defeat the purpose though. And that would probably lead to the placebo effect. But you don't want that to happen. So, okay? All right. That leads us to the notion of what they call a blind study. There we go. So really what I just described as best I could is a blind study. That's when the participants themselves do not know if they're getting a placebo or they're getting the treatment. Now, I don't know if all experiments are like that, but to me it seems like they should be, because again, if you tell them, you're getting a fake treatment, I mean, that would kind of like defeat the purpose of using a placebo in the first place. Okay? All right. Again, going back to that alcohol memory example, you're not going to tell the control group what they're getting is non-alcoholic beer. Okay? You're not going to tell them that, because that would, again, defeat the purpose of the experiment. All right. And to really make it, and to really help, what they can also do, the people running the experiment, the administrators, the ones that are actually giving the treatment, they could ensure that the administrators do not know who's getting the placebo and who doesn't. So in other words, not just the participants don't know if they're getting the treatment or not, but the ones who administer the test, the ones that interacting with the participants, they may not know who's getting the placebo or not. That's what we have. We have then what's called a double-blind study. So going back to that example with medicine, with medicine, the doctors that are interacting with the patients, the doctors also may not know if someone is getting a placebo or the actual medicine. They may not know. I mean, could that be kept from a doctor? I don't know, but then you can have what's called a double-blind study. So in a blind study, the participants don't know if they're getting the treatment or placebo. In a double-blind study, it's not just the participants, but the ones who are interacting with them, the ones that are actually giving them the medicine. They may not know either. Okay. So here's another example. So here's just an example I want to do quickly. Although the first one's probably easy based on what I wrote already, but that's okay. Suppose you have a group of students who are told to listen to music while taking a test, and their results are compared to a group taking a similar test or the identical test, I guess, but they're not listening to music. Now one you could probably guess would be an experiment, right? You have two groups. One group is getting some kind of treatment and the other group is not. Or, one group is getting administered something, the other group is not. Hence, you got an experiment. For the temperature here, the temperature on randomly selected days throughout the year are measured. Well, there you're just measuring something, right? You don't have two groups. You're just measuring something, so you have an observational study. Not too much there. Okay. Are there any questions on that? Okay. With data, again, in statistics, you're going to be dealing with data, right? With data, you're going to be dealing with that. Now, there's really two kinds of data here. There's quantitative data and there's qualitative or categorical data. Quantitative data is the data that's numerical in nature, and you can perform arithmetic on it, and it makes sense to do that. Okay? For instance, you might be asking, like the example I gave, you're asking people through a survey how many movies last month did they watch on Netflix or Hulu, right? And you want to find out on average how many, you're asking that through a survey, excuse me. But you would get numbers, like some people said 0, some people said 1, some people said 2, and so on. But those are the kinds of that's the kind of data you can perform calculations on. Like you could add, take the average, that kind of stuff. Or again, going back to the number of hours per week college students read, that would be quantitative data. The number of hours, right? It's an amount. It's an amount of something. So you can perform arithmetic calculations on that. In other words, it makes sense to add up and say the total number of hours reading or the total number of movies people watch on Netflix last month, whatever. And basically, the other kind of data is categorical data. That helps you classify objects under investigation, but basically for us, it's going to be either quantitative or qualitative data. And if it's not quantitative, it has to be qualitative. For instance, you might ask a group of people what their favorite color is. That would be qualitative data, right? You can't do arithmetic calculations with this, right? I mean, if you were to add up colors and try and take an average, does that even make sense? Well, no. So that's what happens here. And here are some other examples. Like if you want to know how much money people spend on candy, or even, how much money you spent on candy recently, right? $3, $6.50, $8, $11.10, that kind of stuff. That would be quantitative data because it makes sense to add up and do arithmetic on it, okay? You could do arithmetic calculations on it. Okay? Okay. Good. All right. Okay, but you got to be, and also here's another one below it. How many miles, if you're asking people in the gym, how many miles a week do they run? 1 mile, 2 miles, 8 miles, whatever. But that's quantitative data. That's numbers you can work with. You can do calculations on. It makes sense to say, what's the total number of miles a group of people ran in a week? Something like that. Now, you got to be careful, though, because not all numbers give you quantitative data, right? For instance, Social Security numbers, right? That doesn't make sense to add up Social Security numbers together, right? That doesn't make sense at all. Or the average Social Security number, that wouldn't work. Or like ID numbers, for instance, right? That probably won't, you can't do arithmetic calculations on that either. Or zip codes, right? That also, is not quantitative data. Or telephone numbers also, Again, there are many examples of numbers that are not quantitative data, they're qualitative data. Okay? It would not make sense to perform arithmetic calculations on them. Okay. That's what I'm trying to say. Okay, let's do another example. So here we want to classify each kind of measurement here as quantitative or qualitative. Okay, let's do that. So again, if you can do calculations on it, quantitative. If you can't, it's qualitative. So the age in years of each person in a sample, that's quantitative, right? It does make sense to do calculations on age. It's an amount, right? It's some kind of amount, how old they are, how long they've been living since they were born, right? You know, that is something you could do calculations with. So that's quantitative. You know, if you have a sample of chickens and you look at the number of eggs those chickens lay, each chicken laid by each chicken, that's quantitative, right? That's an amount. You know, you could add up the total number of eggs, or on average, each chicken lays this much in a certain amount of time. You know, that's quantitative data. Time in line to buy groceries, that's quantitative also. You could do calculations with time. Okay. Favorite baseball team? Well, that's qualitative, right? That should be easy to see. Okay. Here's another one, brand of toothpaste that people have used recently. You know, toothpaste brand, you really can't do calculations with that. So that's also qualitative.